I guess I'm just gonna have to sit at the kiddie table playing Tinker Toy for a while with these on and off till Steve Ward goes into more details about his setup. If you haven't seen his, oh my god, you need to go look at this man's got a sick fit, you know, he's pushing close to 1,000 watts and he's getting an insane like 7-8 inch or more flame, and you know, he's got a MOSFET, he's got a heat sink on his MOSFET like this size, and it doesn't even get hot after running that. So I mean, it's just an example. You get your perfect Class E switching, you can pull off super high efficiency. Just kind of seeing how this works. So, you know, I showed in the last video just how the oscillator works, and part of my problem was I was kind of being lazy and trying to figure out an ideal secondary I could wind with wire that I had laying around, and I actually had enough on this random spool to wire a resonator that actually had a much lower frequency than I thought it would be. So I originally wound this all the way down or close to it, and that gave a resonant frequency of this coil close to 6 megahertz. As I've noticed, the lower in frequency I run this, the less power it pulls. So, you know, I was able to, let's just say, find it in between, tuning this oscillator to around 6 megahertz to where this would break out. It just wasn't a very powerful breakout, but it was a nice little breakout, and it pulled hardly no power. That's because I was running this at such a low resonant frequency. So what I did was I took off enough turns to bring it up to about close to 8 or 9 megahertz like I have been, and I might continue to do that, but the problem is this wire is too small, this coil is too small. But at any rate, by doing that, you know, it's works like how I would expect now, because at the higher frequencies this is putting out much more power, and if I kind of meet that somewhere in between, then it gives pretty good output. So I'll cut this on, and so right now I've got it at about 23 volts, so I'm just going to crank the pot a little bit to get it to come on. So now it's on, and it's pulling, you know, it's pulling kind of close to the other setup. You can see that's the frequency. Well, it's kind of dancing around a little bit. It's close to about, you know, 7-8 megahertz right now, and I'll tune this, get a little higher output. See, we're about close to 9 megahertz. As per usual, you know, it's going to pull more power as I crank the frequency up, but right around there you go. That was another little interesting dip there, but right around there is where I'm trying to run it, around 9 megahertz. So it's pretty close to the last setup I had, and I mean, you know, it is pulling some juice, and so you can see that little screws about getting pretty dang red there. So I don't have a fan on yet, but let me just cut the power up a little more. So I kind of do the same thing, back the pot down slightly so it's pulling just a little under 3 amps. Then I can keep cranking that power up. So we're about 40 volts, pulling some good juice again. Of course, that little screw right there is getting way too hot, so obviously that's not gonna work. But yeah, you know, cool little flame. Back that down some. If I drop the frequency down, it doesn't really change the output a whole lot, but it is dropping that current. So now I'm closer to 8.5 megahertz. If I go back up to closer to 9, it just starts pulling more current. Flame increases very slightly. So it's looking like at this output or so, about 8.5 megahertz is pretty good. So that's cool. I mean, so this one works sort of similar to the last one. It's got a smaller resonator, and I'm going to need to put a bigger screw on there, but I don't think I'm going to use this coil, because to get it higher in frequency, it's going to be way too tiny by the time I pull enough turns off of there. So my buddy Rambo's still holding up pretty good. He's just chilling. And, you know, what I probably should do is swap FETs just to see what happens, but this one's kind of working okay so far. I just don't have it switching too great. It's becoming an easier process. One tool which is great is Teslaundmehr, and I find this really handy. I've been using it for a while, but you know, you could just plug in your values. So that coil I just ran, that resonator I just ran, these are the values. It's 32 AWG, a little under an inch diameter. You can see it'll plug in your values for you. So at approximately close to a little bit over 1.6 inches, that's what that coil was. So this is an approximation, but that approximation brought me to about 5 or 6 megahertz. And that's around exactly where it was resonant off the LC circuit when I was tuning it. So now that it's closer to, you know, 8 or 9, you know, you could see that's when I'm down to about this many turns or so, because I've just removed quite a few of them. So this actually does work out to, you know, to real world values fairly close. It'll put you in a ballpark. So that's probably the easiest way to do it. You know, okay, my LC circuit's running at 12 megahertz. I need to wind a 12 megahertz coil. You know, just to make it easier, just plug in your values and see how many winds you need on the diameter former you have. That'll put you in the ballpark. Slight tuning from there will get you dead on. Put a little chunk of glass on there now to see what that does. So I've detuned it to below its resonant frequency. Which for some reason works kind of the opposite of how I thought it would. So it's detuned to the point where it's not really pulling a whole lot. One thing I did notice though, with this glass, I'm able to pull out the arc quite a bit by drawing it to this little file here, as opposed to, you know, how small it looks normally. That's what it's doing, pulling about 45-50 watts. It's a very small flame, but it does want to pull out almost 2-3 times the length with that glass on there. So when I cut the power up, let's see, let's do about 100 watts. Yeah, so you can see how it's doing. It really wants to kind of pull that out a good ways. And having the fan not going definitely helps stabilize that a little bit. See, it still kind of wants to jump around funky like. And let me try about 40, 45. At 45, it starts to pick up pretty decent. So you can see that's what I wanted to do. I wanted to stretch out, but I wanted to do it on its own. But I believe I'm kind of running a losing battle using this FET here. And this FET, you know, it's actually, I tell you what, detuning it like that, this thing really didn't get as hot as I thought it would running for that little period. It wasn't very long at all, but I just don't have a lot of faith in this FET. But, you know, I don't know what the difference is. I don't know why this is acting slightly different compared to my other circuit, when all I've done was take the DC cap off and throw this slug on here as my RF choke. Primary is pretty much the same value, and I'm slightly detuned it compared to my other coil. But this actually, while my other coil at around that wattage puts a little bit bigger flame out, it's actually quite a bit bigger than that. I can't draw that one out to the length I can this one. I don't really know the physics behind that, but that's pretty much how it's working.